In this lesson, we will learn how to solve one-step inequalities. We've already learned that an equation has two expressions that are equal, whereas an inequality has two expressions that are not equal. We use symbols such as greater than, less than, greater than or equal to, less than or equal to, and not equal to for inequalities, mostly the first four. A one-step inequality, similar to a one-step equation, means that we have to do one inverse operation to solve our equation or inequality. This means that we may distribute or we may combine and simplify on each side, but we will only do one inverse operation to solve our equation. For our equation, x plus 1 equals 4, we know that we would do the inverse operation and we would subtract 1 from each side, so we have x equals 3. We did one inverse operation, subtraction, to undo our addition. Now if we had the inequality, x plus 1 is greater than 4, we can think of some numbers that make this true. We know if we put 3 in for x, 3 plus 1 equals 4, so that's not greater than 4, so 3 does not work. But if we put 4 in, 4 plus 1 is greater than 4, 5 plus 1 is greater than 4, so we know that all of our numbers have to actually be anything greater than 3. So we actually solve this by doing the same process that we would for our equation, but instead we keep our inequality symbol, so we have x is greater than 3. Let's look at another example. We have x minus 1 is less than 5. Think about which numbers make this true. If we have 6 minus 1, that gives us 5. That's not less than 5. If we went up and did 7 minus 1, well, that would be 6, so that's certainly not less than 5. So we know we need to get smaller. If we had 5 minus 1, that gives us 4, so we know that's true. But we could keep going, and we actually, again, do the same inverse operation, and we see that x has to be less than 6 to make this true. That makes sense because, as we said, if we do 6 minus 1, we get 5. So we know that our number has to be slightly less than 6 if we want to subtract 1 and get something that's less than 5. Any number that's slightly less than 6, when we subtract 1, will give us a number that's less than 5. In other words, we follow the same rules for addition and subtraction inequalities as we do for solving equations, but we keep the inequality symbol. So when we originally had a greater than symbol, we finished with a greater than symbol. If we originally had a less than symbol, we finish with a less than symbol. Now let's look at multiplication and division. We have the inequality 2x is greater than 6. Sort of like before, we could try numbers. We know that 2 times 3 equals 6. So 6 is not greater than 6, so 3 will not work. But anything greater than 3 will give us a product that's anything greater than 6. So we would solve this just the same way we would do with an equation. Since we have 2 times x, our inverse operation is division, and when we divide both sides by 2, we get x is greater than 3. However, before we draw any conclusions, let's look at something where we multiply by a negative. We know that in our multiplication rules, a negative times a negative is a positive times a positive is obviously a positive, and a positive times a negative is a negative. So if we have negative 2x is greater than 6, and we were to solve this with our same rule, we would divide both sides by negative 2, and we would have x is greater than negative 3. But let's look back at our equation. Let's choose something that's greater than negative 3. For example, negative 2. Negative 2 times negative 2 is positive 4. This is not greater than 6. So something is different. In other words, because we know that the bigger digits of our negative numbers are actually more negative, our rule kind of reverses. So we actually want x is less than negative 3 to make this equation true. If we look at a number line, we have negative 4, -3, -2. And we want all of the numbers that are less than -3, not including -3. So let's test this to make sure it makes sense. If we went back to our original equation and we chose -2, which we said shouldn't work, then we have -2 times -2, which is 4, is greater than 6. And that does not work with our inequality, which is good. We're saying that -3 also will not work. -3 times, or -2 times -3 gives us 6, which is not greater than 6. So that's good. That also doesn't work. Now we want something that is even more negative or less than -3. So we'll try -4. -2 times -4 gives us +8, which is greater than 6, which does work, which is good because we wanted it to work. We notice that our sort of cutoff point is -3, because if this was an equation, then we know that -2 times -3 equals 6. Since it's an inequality and we want our product on the left to actually be greater than our +6, we know that in order for it to be greater, we need to multiply by another negative, because a negative times a negative equals a positive, and we need a positive number if we want to be greater than +6. And we need our product to be bigger than 6, so we need to multiply by a number that's even more negative than -3. This may seem a little confusing, but in other words, we follow the same rules for multiplication and division for inequalities as for equations, except if you multiply or divide by a negative on both sides, you must reverse your inequality symbol. So if we had less than, we must change it to a greater than, and vice versa. And if you had less than or equal to, you must change it to a greater than or equal to, and vice versa. Only when the inverse operation requires us to either multiply or divide by a negative number. Now let's try some examples. I'm going to do examples 2 and 3 from the 4th page of your packet. I'm skipping the 3rd page because the 3rd page is all addition and subtraction, or combining, and we keep the same symbol as we start with when we do that. So if you look at page 4, this requires us to do multiplication or division. Number 2 says -15m is less than or equal to -75. Since we're multiplying -15 with m, we need to divide by -15 on both sides, because that's our inverse operation. Our 15s, or -15s, cancel out, and we get m, and we get 5 on the other side. However, we need to flip our symbol to greater than or equal to, because I see a negative and a negative that we're dividing by on both sides. We, of course, always want to check to make sure that our answer makes sense. So if we were to substitute 5 into our inequality, -15 times 5 is -75. This is not less than or equal to -75. If we substitute in 6, which should work because 6 is greater than or equal to 5, we have -15 times 6 is less than or equal to -75. This simplifies to -90 is less than or equal to -75, which is true, which is exactly what we wanted. Just to be safe, let's test one on the other side. In other words, let's test a point that we don't think is true, such as x is 4. -15 times 4 is less than or equal to -75. This is -60 is less than or equal to 75. But -60 is closer to the positives, so we know that this does not work, which is good, because our solution here says that m is greater than 5. Since 4 is not greater than 5, it shouldn't work, so our solution is correct. The last example I'll do for you is number 3. We have -1 is greater than b divided by 3. The inverse operation here, since we have b divided by 3, is to multiply by 3/1 on both sides. Our 3's cancel out, so we're left with just a b on the right, and we have 3 times negative 1, which gives us negative 3 on the left. Now be careful here. Since we did not multiply or divide by a negative on both sides, even though I actually see a negative number here, that wasn't part of the inverse operation. So I keep the symbol exactly like it was, and I bring it down. So I have negative 3 is greater than b. Our final step is always to simplify it so that the variable comes first. So I have b is less than negative 3. Because before, I had my b with the smaller side, so my b is smaller than my negative 3. So I still want the smaller side of my inequality to be with my variable. I could, of course, check this and make sure that it's true, just like I did with the others. That concludes our video for today. The key concepts were, we keep the same symbol, as in less than, greater than, less than or equal to, greater than or equal to, when we're doing addition or subtraction, and we follow our same rules that we followed for solving equations. However, when we multiply or divide, we follow the same rules again, except that when we multiply or divide by a negative number on both sides as part of our inverse operation, we reverse the inequality. So our greater than becomes a less than symbol, a less than becomes a greater than symbol, etc. And this is because when you are looking at your negative numbers, the more negative numbers are actually smaller. And we know that when we multiply or divide by a negative number, a negative times a negative is a positive, and a negative times a positive is a negative.